Hello guys, so we'll move to the next question on projectile motion. So this time a projectile is launched with 20 meters per second from the bottom of an inclined plane at an angle of 75 degree. The inclined plane makes an angle 30 degree with the horizontal. Find the distance traveled by the projectile along the inclined plane. So the question is, there is an inclined plane. This makes an angle 30 degree with the horizontal, and a projectile is launched with respect to the horizontal axis 75 degree, and the projectile is launched at 20 meters per second. You need to find the distance traveled along this inclined plane. What is the distance traveled along this inclined plane? So how do you do this? I'm going to use s equal to ut plus half gt squared, and we know there is no acceleration components along the horizontal direction, so I can say this part will be 0. So the first, I'm going to divide this 20 meter per second, this speed, into two perpendicular components. The one is I can divide along the horizontal axis, which is 20 cos 75, and the other one is vertical direction, that is 20 sin 45. So that is my first step, dividing the velocity vector into two perpendicular components. So if you do that, if you use this equation, we said this component is 0. So what is the distance traveled by the projectile along the horizontal direction? So the first, let's say our projectile is traveling along the horizontal direction a distance d. Okay, so this total distance is d. If we say the projectile, the inclined plane makes 30 degree with respect to the horizontal axis, I can divide this displacement vector into two perpendicular components. Along the x direction we will get d cos 30, because this is 30 degrees, so if you divide towards the angle you will get cos 30, and if you divide away from that we will get d sin 30. So if you use this equation, the distance traveled along the x direction is d cos 30 degree, which is equal to the velocity is in the horizontal is 20 cos 75 into time. So from here I can find the value for time. So this is my first equation, and the second equation I'm going to use s equal to ut plus half at squared now in the vertical direction. In the vertical direction, the distance traveled by the projectile is actually d sin 30, which is equal to ut. So 20 cos 75, because here we said the vertical component, velocity vertical component is 20 sin 75. So 20 sin 75 into t, and remember this has to be minus because we throw the projectile upward but the gravity is downward, so minus sign half into 10 into t squared. So this is my second equation. So if you know the equation 1 and 2, you can simply eliminate t from both the equation. You'll find the value for this t. So how do you do this? I'll substitute for, here we have subjected t, so t is equal to d cos 30 divided by 20 cos 75, and just substitute here. So d sin 30 is there, 20 sin 75 is there. Instead of t, I am going to replace d cos 30 by 20 cos 75 minus this minus sign, half 10 into t squared. For t squared mean we need to square this factor, d cos 30 divided by 20 cos 75 square. So from here the rest is just you need to simplify the equation. So if you simplify the equation, you will get d equal to 80 cos squared 75 over cos squared 30 into cos 30 tan 75 minus sin 30. So if you substitute all the values, you will get d is very close to 19.91 meters. I hope you got the idea. So I'll quickly revise the idea. The question was you need to find distance d. So what I did is I divided this distance into two perpendicular components. The one is along this x direction. So I can say if this distance is d, this would be d cos 30 and the vertical would be d sin 30. So this is my first step. And also here the projectile is launched with 20 meter per second and which makes an angle 75 degree. So I divided again this velocity component into two perpendicular direction. One is 20 cos 75, other one is 20 sin 75. And I use s equal to ut plus half at squared, and you should know this component is 0 and just the rest is just simplification. I hope you got the idea. If you like my videos, please subscribe to my channel. Thank you for watching.